From the very first flicker of conscious thought, humanity has been captivated by the grand, echoing questions that ripple through the cosmos and within the depths of our own being. Why are we here? Where did everything come from? What is the purpose of this fleeting dance we call life? These are not mere academic inquiries. They are the fundamental yearnings of the human spirit, etched into our very DNA, driving us to seek meaning and understanding in a universe that often feels both infinitely vast and intimately personal. Imagine our earliest ancestors, huddled around a crackling fire under a sky ablaze with stars. Without the glow of city lights, the celestial tapestry would have been an overwhelming spectacle, a dizzying display of cosmic power and mystery. They would have gazed up, perhaps with fear, certain with awe, at the silent, majestic procession of the constellations, the predictable cycles of the moon, and the life-giving warmth of the sun. These celestial rhythms dictated their lives: when to plant, when to hunt, when to seek shelter. The changing seasons, the sudden fury of a storm, the inexplicable miracle of birth, and the undeniable finality of death. All these phenomena would have stirred within them a profound sense of wonder, coupled with a desperate need for explanation. They sought patterns, connections, and meaning in a world that was both beautiful and terrifying. This primal wonder, this shared human experience of gazing up and wondering down, is the ancient wellspring from which both religion and science, in their earliest forms, emerged. In their attempts to make sense of the world, early humans began to weave narratives, stories that explained the origins of the earth, the heavens, and themselves. These were the first myths, born from observation, imagination, and a deep spiritual intuition. The sun became a god, traversing the sky in a fiery chariot. The moon became a goddess, presiding over the tides and the mysteries of the night. The thunder was the voice of a powerful deity, and the fertile earth, a nurturing mother. These stories were not just entertainment. They were their cosmology, their physics, their biology, and their ethics, all rolled into one. They provided comfort in the face of the unknown, explained natural phenomena, and offered guidance on how to live in harmony with the world and each other. As these myths evolved and became more formalized, they gave rise to organized religions, with their rituals, sacred texts, and established priesthoods. These early religious systems provided a framework for understanding existence, a moral compass, and a sense of community and belonging. They answered the big questions in ways that resonated deeply with the human soul, offering solace, purpose, and a connection to something transcendent. For thousands of years, these mythic and religious frameworks served as humanity's primary lens for understanding the universe. But then, a different way of asking the same fundamental questions began to emerge. This was the birth of what we now call the scientific method. It wasn't a sudden revolution, but a gradual evolution, building upon the meticulous observations of ancient astronomers and philosophers. Instead of seeking answers primarily through divine revelation or ancestral stories, this new approach emphasized observation, experimentation, logical reasoning, and the formulation of testable hypotheses. Think of the early Greek philosophers like Thales, who tried to explain the world in terms of natural principles rather than divine intervention, or the Islamic Golden Age scholars who meticulously observed the stars and developed algebra. Later, figures like Galileo, Newton, and eventually Einstein refined this method, building a cumulative body of knowledge based on empirical evidence and mathematical precision. The scientific method became a powerful tool for dissecting the universe, for understanding its mechanisms, and for predicting its behavior. It sought to answer the how questions. How do planets move? How do stars shine? How does life evolve? It offered a different kind of truth, one that was verifiable, repeatable, and constantly open to revision based on new evidence. So we are left with a profound and fascinating question. Can both science and faith seek truth in different ways? At first glance, they'd often appear to be in direct conflict, two opposing forces vying for the soul of humanity. Science, with its emphasis on empirical evidence and logical deduction, often seems to dismiss faith as irrational or superstitious. Faith, with its reliance on revelation and spiritual experience, can sometimes view science as reductionist or even sacrilegious. Yet, a closer look reveals a more nuanced relationship, one where conflict is not inevitable, and where a shared quest for truth might actually unite them. Science, in its purest form, seeks to understand the natural world, to uncover its laws, and to explain its phenomena. It operates within the realm of the measurable, the observable, the testable. It asks, how does the universe work? Faith, on the other hand, often seeks to understand meaning, purpose, and ultimate reality. It operates within the realm of the spiritual, the transcendent, the unquantifiable. It asks, why does the universe exist? What is its ultimate meaning? These are different questions, pursued with different methodologies, but both are driven by a fundamental human desire to comprehend the totality of existence. Consider the possibility that science and faith are not enemies, but rather two different lenses through which to view the same magnificent reality. Imagine a grand cathedral. A scientist might meticulously study its architecture, its structural integrity, the chemical composition of its stones, the physics of its stained glass windows. They would understand how it was built, how it stands, how light refracts through its glass. This is a profound and valuable understanding. A person of faith, however, might enter the same cathedral and experience a sense of awe, transcendence, and spiritual connection. They might feel the weight of centuries of prayer, the presence of the divine, the beauty of the sacred space. They would understand why it was built, what it means, what it inspires. Both perspectives are valid, both reveal a truth about the cathedral, but they are different kinds of truth. One explains the mechanics, the other reveals the meaning. Neither negates the other. In fact, they can enrich each other. The scientific understanding of the cathedral's construction can deepen one's appreciation for the ingenuity of its builders, while the spiritual experience can imbue the scientific facts with a deeper sense of purpose and wonder. This is the core premise of our journey, to explore the edges where these two seemingly disparate ways of knowing meet, where the known fades into the unknown, and where the questions of science begin to echo the ancient inquiries of faith. We will not seek to prove or disprove God through scientific equations, nor will we attempt to explain away scientific discoveries with religious dogma. Instead, we will seek to understand how these two powerful human endeavors, both driven by a profound sense of curiosity and a relentless pursuit of truth, can coexist, inform each other, and perhaps even lead us to a more holistic and profound understanding of reality. We will embrace the mystery, recognizing that some questions may never have definitive answers, and that the beauty often lies in the asking, in the wondering, in the continuous journey of exploration. This journey is not about finding certainty, but about finding harmony in the uncertainty, about discovering a deeper sense of wonder in the vast, unfolding mystery of existence. It is about recognizing that the universe is not just a collection of particles and forces, but a grand narrative, a cosmic poem, waiting to be read by both the scientific mind and the spiritual heart. As we embark on this exploration, let us hold both curiosity and reverence in equal measure, allowing the insights from both science and faith to illuminate our path into the profound secrets of existence. In the beginning, Genesis versus the Big Bang, creation stories versus cosmology. As we continue our journey into the profound mysteries that lie at the intersection of faith and science, let us now turn our gaze to the very beginning, to the ultimate question of origins. Every culture, every civilization, every human heart has, at some point, grappled with the enigma of creation. Where did it all come from? How did something emerge from nothing? For millennia, these questions have been answered through powerful narratives, sacred stories passed down through generations, offering comfort, meaning, and a sense of divine purpose. In the Western tradition, perhaps no creation story is more iconic, and influential than the biblical account of Genesis. Yet, in the last century, science has offered its own compelling narrative of cosmic origins, the Big Bang Theory. At first glance, these two accounts seem to stand in stark opposition, a clash between ancient revelation and modern discovery. But as we delve deeper, we might find not a battle, but a fascinating dialogue of poetic resonance that speaks to the shared human quest for understanding the ultimate beginning. The biblical account of creation, found in the first book of Genesis, paints a vivid picture of a universe brought into being by divine decree. In the beginning, God created the heavens and the earth. With these majestic words, a timeless narrative unfolds. Light separated from darkness, the firmament dividing the waters, dry land emerging from the seas, vegetation bursting forth, the sun, moon, and stars set in their places, creatures filling the waters and the air, and finally humanity made in the divine image. This is a story of intentionality, of a purposeful act of creation by an omnipotent God, unfolding over 6 days, culminating in a day of rest. It is a narrative rich in symbolism, designed to convey theological truths about God's power, order, and relationship with creation. It speaks to the who and the why of creation, emphasizing divine agency and purpose. For billions of people across millennia, this account has provided a foundational understanding of their place in the cosmos, a sense of belonging within a divinely ordered universe. It is a story that speaks to the heart, offering meaning and solace in the face of the unknown. In stark contrast, the scientific story of the Big Bang offers a narrative rooted in observation, mathematical models, and empirical evidence. It describes a universe that began approximately 13.8 billion years ago from an incredibly hot, dense state, smaller than an atom. From this singularity, space itself began to expand, carrying with it the nascent ingredients of the cosmos. In the first fractions of a second, fundamental forces separated, particles formed, and the universe cooled enough for light to travel freely, creating the cosmic microwave background radiation, the faint afterglow of the Big Bang, a powerful piece of evidence for the theory. Over billions of years, gravity pulled matter together, forming the first stars, then galaxies, and eventually the complex structures we see today. This is a story of natural processes, of physics and chemistry unfolding according to fundamental laws, leading to the emergence of complexity from simplicity. It speaks to the how of creation, describing the mechanisms and timeline of cosmic evolution. It is a narrative built on rigorous testing, constant refinement, and the commitment to understanding the universe through empirical observation. So, what came before time? This is a question that both Genesis and the Big Bang Theory, in their own ways, grapple with, and it pushes the very limits of human comprehension. In the Genesis account, God exists prior to creation, outside of time, bringing time itself into being as part of the created order. The concept of a timeless God, existing eternally, is central to many theological traditions. Time, in this view, is a feature of the created universe, not a constraint on the Creator. For the Big Bang, the question of before becomes equally problematic. The theory describes the expansion of space and time from a singular point. If time itself began with the Big Bang, then asking what came before is like asking what is north of the North Pole. The question loses its meaning within the defined framework. Some physicists propose speculative theories, such as a cyclic universe that undergoes endless Big Bangs and big crunches, or a multiverse where our Big Bang is just one event in a larger eternal cosmic landscape. However, within the standard Big Bang model, the singularity represents the boundary of our current understanding, a point beyond which our physical laws break down. Both narratives, therefore, confront the profound mystery of a beginning that transcends our ordinary experience of linear time, hinting at a reality that is fundamentally different from our everyday perception. Time itself, then, can be seen as a creation, both in philosophical and physical interpretations. Philosophically, many spiritual traditions view time as an illusion, a construct of the human mind or a dimension within a larger eternal reality. For example, in some Eastern philosophies, the concept of Maya suggests that the material world, including time, is an illusion. In a theological context, if God is eternal and outside of time, then time is a created aspect of the universe, a framework within which creation unfolds. Physically, Einstein's theory of relativity revolutionized our understanding of time, revealing it not as an absolute, unchanging backdrop, but as an integral part of spacetime, a flexible fabric that can be warped by gravity and influenced by motion. The Big Bang theory posits that time, as we understand it, began with the universe's expansion. Before that moment, the very concept of before loses its meaning. This convergence of philosophical and physical interpretations suggests that time is not merely a given, but a profound aspect of reality that emerged with the universe itself, a dynamic dimension that is deeply intertwined with the fabric of existence. It is a secret that reveals the universe to be far more fluid and interconnected than our everyday experience might suggest. Is the Big Bang the scientific version of let there be light? This is a question that often sparks debate, but it also highlights a profound poetic similarity between the two narratives, despite their different languages. In Genesis, God's first command is let there be light, and light appears, dispelling the darkness. In the Big Bang theory, after the initial singularity, the universe was an opaque, superheated plasma. It was only after about 380,000 years, when the universe had cooled sufficiently for electrons to combine with atomic nuclei, that light was able to travel freely through space. This event, known as recombination or decoupling, marked the moment when the universe became transparent, and light, in the form of the cosmic microwave background radiation, flooded the cosmos. This is often referred to as the first light of the universe. While the mechanisms are vastly different, divine command versus natural physical processes, the outcome is strikingly similar, a transition from darkness or opacity to light, marking a fundamental shift in the nature of reality. This parallel is not about scientific validation of religious texts, or vice versa, but about recognizing the shared human intuition about the importance of light in the act of creation, a universal symbol of emergence, clarity, and the beginning of all things. It speaks to a deeper, almost archetypal understanding of creation, where light is not just a physical phenomenon, but a metaphor for consciousness, order, and the unfolding of existence. The poetic similarity of both stories, despite their different languages, is perhaps the most profound takeaway. Genesis speaks in the language of myth, metaphor, and divine revelation, conveying truths about purpose, meaning, and relationship. The Big Bang speaks in the language of mathematics, physics, and empirical observation, conveying truths about mechanisms, processes, and timelines. One tells us why there is something rather than nothing, and who initiated it. The other tells us how that something unfolded over cosmic time. They are not competing explanations for the same thing, but complementary narratives addressing different dimensions of reality. Imagine two poets describing the same sunset. One might speak of the fiery embrace of the sun and the earth, the divine brushstrokes of a celestial artist, evoking feelings of awe and spiritual connection. The other might describe the scattering of light particles in the atmosphere, the specific wavelengths of color, the physics of atmospheric refraction, evoking a sense of intellectual wonder at the laws of nature. Both are describing the same sunset, both are conveying a truth about it, but they are using different languages and focusing on different aspects. Similarly, Genesis and the Big Bang, when viewed through a lens of appreciation rather than conflict, can be seen as two profound human attempts to articulate the ultimate mystery of existence, each offering a unique and valuable perspective. They remind us that the universe is vast enough to contain both scientific laws and spiritual meaning, and that the human mind is capacious enough to embrace both the poetry of faith and the precision of science in its quest to understand the ultimate beginning. Order from chaos, divine design or natural law, fine-tuning and the anthropic principle. Having journeyed to the very beginning of time and space, exploring the ancient narratives of creation alongside the scientific story of the Big Bang, let us now turn our attention to a profound and often unsettling question. Why is the universe so perfectly suited for life? As we delve deeper into the intricate workings of the cosmos, we encounter a startling precision, a delicate balance of fundamental constants and physical laws that, if even slightly different, would render the universe utterly inhospitable to the emergence of stars, galaxies, planets, and ultimately life itself. This remarkable observation has led to concepts like fine-tuning and the anthropic principle, sparking intense debate and inviting reflection on whether this cosmic order is a testament to divine design or merely a fortunate outcome of natural law. It is at this edge where the exquisite order of the universe meets our human capacity for wonder that the conversation between science and faith becomes most compelling. Why are the laws of physics so precise? This is not a rhetorical question, but a genuine scientific puzzle. Imagine a cosmic control panel with countless dials, each representing a fundamental constant or a law of nature. The strength of gravity, the mass of an electron, the charge of a proton, the speed of light, the strength of the strong and weak nuclear forces. These are just a few of these dials. If any of these dials were set even slightly differently, the universe as we know it would not exist. For instance, if gravity were infinitesimally stronger, stars would burn out too quickly, collapsing into black holes before life could form. If it were infinitesimally weaker, matter would never coalesce into stars and galaxies, leaving a diffuse, lifeless cosmos. If the strong nuclear force which binds atomic nuclei together were slightly weaker, no stable elements heavier than hydrogen would form, preventing the existence of carbon, oxygen, and all the other elements essential for life. If it were slightly stronger, hydrogen would have fused into helium too rapidly in the early universe, leaving no hydrogen for stars to burn over billions of years. The list goes on, a dizzying array of precise values that seem almost miraculously calibrated for the emergence of complexity in consciousness. This precision is not just a curiosity. It is a profound mystery that demands explanation. It's as if the universe is a perfectly tuned instrument, playing a symphony of existence, and every note, every chord is precisely where it needs to be for the music to play. These fundamental constants of nature, gravity, electromagnetism, the strong and weak nuclear forces, and the masses of elementary particles, are the bedrock upon which the entire universe is built. They are the fixed parameters that govern every interaction, every process from the smallest subatomic particle to the largest galaxy cluster. And their values are not arbitrary. They are precisely what they are, and if they were different, the universe would be fundamentally different. For example, the electromagnetic force, which governs light, electricity, and magnetism, is responsible for holding atoms together and for all chemical reactions. If it were too strong, electrons would be pulled too tightly to atomic nuclei, preventing chemical bonds and the formation of complex molecules. If it were too weak, electrons would not be bound to nuclei at all, leading to a universe without atoms. The delicate balance between these forces allows for the formation of stable atoms, the complex chemistry of carbon-based life, and the long-lived stars that provide the energy necessary for planets to form and evolve. This intricate dance of fundamental constants is a testament to the profound order embedded within the universe, an order that seems almost designed for the emergence of life. It's a cosmic recipe, and every ingredient is measured with astonishing accuracy, ensuring the perfect outcome. This leads us to the concept of the Goldilocks zone, not just for planets, but for the entire universe. Just as a planet needs to be just right in its distance from a star to have liquid water, the universe itself seems to be just right and its fundamental properties for life to exist. This appearance of intentionality, this uncanny fit between the universe's properties and the requirements for life, is what gives rise to the fine-tuning argument. It's not just one or two parameters that are finely tuned, but dozens across different scales and different physical laws. The initial conditions of the Big Bang, the rate of cosmic expansion, the density fluctuations in the early universe, all seem to be precisely calibrated. If the universe had expanded too quickly, matter would have dispersed too thinly to form stars and galaxies. If it had expanded too slowly, it would have collapsed back on itself before life could emerge. This remarkable coincidence, this apparent conspiracy of cosmic parameters, is what makes the universe seem almost designed for us. It's as if the universe is a perfectly crafted stage, and we, the conscious observers, are the intended audience, or perhaps even the actors in a grand cosmic play. The question then becomes, is this intentionality real, or is it merely an illusion born from our limited perspective? This is where the debate between intelligent design and blind chance enters the conversation. The intelligent design argument posits that the fine-tuning of the universe is so improbable, so exquisitely precise, that it cannot be attributed to random chance. Therefore, it must be the product of an intelligent designer, a cosmic architect who intentionally set the parameters of the universe to allow for the emergence of life and consciousness. This perspective often aligns with theological views of the Creator God who actively shapes and orders the cosmos. Proponents of intelligent design see the universe as a masterpiece, bearing the unmistakable signature of its artist. They argue that the sheer statistical improbability of all these parameters, falling into the narrow range required for life, points strongly towards a purposeful origin. It's like finding a perfectly functioning watch in the middle of a desert. The complexity and functionality suggest a designer, not a random assembly of parts. This view offers a comforting sense of purpose and meaning, suggesting that our existence is not an accident, but a deliberate act of creation. It provides a framework where scientific discovery can be seen as uncovering the intricate workings of a divine plan, revealing the genius of the Creator through the elegance of natural laws. On the other hand, the argument for blind chance, often supported by scientific naturalism, suggests that while the fine-tuning is indeed remarkable, it does not necessarily imply a designer. From this perspective, the universe simply is, and we happen to find ourselves in a universe where the conditions are suitable for life, because if they weren't, we wouldn't be here to observe them. This is known as the weak anthropic principle. The universe must have properties that allow for the existence of observers, because if it didn't, there would be no observers to observe it. It's a selection effect. Imagine a puddle of water that marvels at how perfectly the hole in the ground fits its shape. The puddle exists because the hole exists. Similarly, we exist because the universe's parameters are suitable for our existence. This view often points to the vastness of the cosmos and the possibility of a multiverse. If there are an infinite number of universes, each with different fundamental constants and laws, then it is statistically inevitable that at least one of them would have the precise conditions necessary for life to emerge. In this scenario, our universe is not special in its design, but merely one fortunate outcome among countless possibilities. This perspective emphasizes the power of natural processes and the role of chance in shaping reality, suggesting that the apparent design is an illusion, a consequence of our limited perspective. It challenges us to embrace the idea that our existence, while precious, might not be the result of a grand cosmic plan, but rather a happy accident in an infinitely diverse cosmos. So, is natural law itself a form of divine will? This is where the conversation becomes most nuanced and potentially most unifying. For many who seek to reconcile science and faith, the laws of nature are not seen as antithetical to divine will, but rather as the very expression of it. Instead of God who constantly intervenes to perform miracles, this perspective envisions a God who created a universe with inherent laws, a self-sustaining system that unfolds according to its own internal logic. In this view, the precision of the physical constants and the elegance of natural laws are not evidence against a designer, but rather evidence for a supremely intelligent and powerful designer who crafted a universe capable of evolving and self-organizing. It's like a master programmer who writes a perfect code, allowing the program to run autonomously and generate complex outcomes. The laws of physics, then, become the divine blueprint, the very language through which the Creator expresses His will. This perspective allows for a harmonious integration of scientific discovery and religious belief. Every new scientific insight into the workings of the universe becomes a deeper understanding of the divine mind, a revelation of the Creator's ingenuity. The universe is not a clockwork mechanism left to run on its own, but a dynamic, evolving system imbued with divine purpose, where every natural process is an act of ongoing creation. This view finds beauty in the predictability of natural laws, seeing them not as limitations on divine power, but as manifestations of divine order and wisdom. It suggests that the very rationality and intelligibility of the universe, its capacity to be understood through scientific inquiry, is itself a profound theological statement, a testament to a universe created by a rational and ordering intelligence. This approach transcends the simplistic dichotomy of intelligent design versus blind chance, offering a third path where the beauty of natural law and the wonder of divine purpose can coexist and enrich each other. It invites us to see the universe not just as a collection of particles and forces, but as a living testament to a profound, underlying intelligence, a cosmic symphony where every note, every harmony, speaks of a deeper, hidden meaning. This perspective allows for a deep sense of awe and reverence, where scientific discovery becomes a form of worship, and where the pursuit of knowledge is seen as a sacred act, revealing the intricate beauty of creation. It suggests that the secrets of the universe are not just about what exists, but about the profound why behind its existence, a question that continues to echo through the ages, inviting us to ponder the ultimate source of all order and beauty. The mystery of DNA, information and complexity. The discovery of DNA, the double helix, stands as one of the most monumental achievements in the history of science. It revealed the molecular basis of heredity, unlocking the secrets of how life replicates and transmits information across generations. But beyond its structural elegance, DNA presents a profound philosophical challenge. How did such an incredibly complex and information-rich molecule arise? The sequence of nucleotides in DNA is not random. It carries precise instructions, a genetic code that dictates the synthesis of proteins, the building blocks of life. This informational content is analogous to a language, a digital code written in the very atoms of our being. For some, the sheer complexity and specificity of this genetic information point directly to an intelligent designer. They argue that just as a complex computer program requires a programmer, the intricate code of DNA requires an intelligent source. The concept of irreducible complexity, where a system requires all its parts to be present and functioning for it to work, is often invoked to suggest that certain biological structures could not have arisen through gradual evolutionary steps. However, evolutionary biology offers compelling explanations for the emergence of complexity through natural processes. Random mutations, while often deleterious, can occasionally be beneficial, providing new raw material for natural selection to act upon. Over vast stretches of geological time, these incremental changes, coupled with the immense power of natural selection, can lead to the accumulation of complex structures and functions. The concept of exaptation, where a feature evolved for one purpose is co-opted for another, also helps explain how seemingly irreducibly complex systems can arise through a series of simpler functional intermediates. Furthermore, the discovery of self-organizing principles in nature suggests that complexity can emerge spontaneously from simple rules, without the need for external design. Think of the intricate patterns formed by snowflakes or the complex behavior of ant colonies, which arise from simple interactions between individual units. While the precise origins of the first self-replicating molecule remain an active area of scientific research, the ongoing progress in fields like abiogenesis, the study of how life arose from non-living matter, continues to shed light on plausible natural pathways. The mystery of DNA, therefore, is not about whether it was designed, but about the profound elegance of its structure and function, and the astonishing capacity of natural processes to generate such intricate information. It invites us to marvel at the universe's capacity for self-organization and the emergence of breathtaking complexity from simple chemical building blocks. The secret here is that the universe is not just a collection of particles and forces, but a grand narrative, a cosmic poem, waiting to be read by both the scientific mind and the spiritual heart. Consciousness, the unfinished symphony. The mystery of consciousness remains one of the most profound and enduring challenges for both science and philosophy. Despite remarkable advances in neuroscience, which have illuminated the brain's intricate architecture and its role in perception, cognition, and emotion, the fundamental question of how physical processes give rise to subjective experience, the feeling of what it is like to be me, remains elusive. This is often referred to as the hard problem of consciousness. We can map brain activity, identify neural correlates of consciousness, and even manipulate brain states to alter perception, but we still lack a complete understanding of how these physical phenomena translate into the rich inner world of subjective experience. Is consciousness merely an emergent property of complex neural networks, a sophisticated illusion generated by electrochemical signals? Or is it something more fundamental, a property of the universe itself, with the brain acting as a receiver or a filter rather than a generator? Scientific theories of consciousness range from purely materialistic explanations, which posit that consciousness is entirely a product of brain activity and will eventually be fully explained by neuroscience, to more speculative theories that suggest consciousness might be a fundamental property of the universe, perhaps even a form of information processing that exists at a deeper level of reality. Integrated information theory, IIT, for example, proposes that consciousness is a measure of the amount of integrated information in a system, suggesting that any system with a high degree of integrated information, not just brains, could be conscious. Other theories explore the role of quantum mechanics in consciousness, suggesting that the brain might exploit quantum phenomena to generate subjective experience. While these theories offer fascinating avenues for research, they still grapple with the fundamental question of how subjective experience arises from objective physical processes. The very nature of consciousness challenges the boundaries of scientific inquiry, pushing us to confront the limits of our current understanding and inviting us to consider the possibility that reality is far more complex and multi-layered than our current scientific paradigms can fully grasp. From a philosophical and theological perspective, the mystery of consciousness often serves as a bridge to deeper questions about the nature of the soul and the divine. If consciousness is not merely a product of the brain, then what is its source? Could it be a manifestation of a universal consciousness, a divine mind that permeates all existence? Many spiritual traditions posit the existence of a soul, an immaterial essence that is the seat of consciousness and identity, and that transcends the physical body. While science, by its very nature, cannot directly measure or detect a soul, the persistent human experience of an inner self, a sense of agency, and a capacity for profound spiritual longing continues to resonate with this ancient concept. The debate between soul and self-awareness, therefore, is not merely a semantic one. It touches upon our deepest intuitions about who we are, what our purpose is, and what, if anything, endures beyond the physical realm. It invites us to consider that the universe is not just a collection of particles and forces, but a grand narrative, a cosmic poem waiting to be read by both the scientific mind and the spiritual heart. As we embark on this exploration, let us hold both curiosity and reverence in equal measure, allowing the insights from both science and faith to illuminate our path into the profound secrets of existence. The nature of miracles, beyond simple explanations. The concept of a miracle, an event that defies the known laws of nature, has always been a point of contention between religious belief and scientific understanding. For many, miracles are direct evidence of divine intervention, a demonstration of God's power to transcend the very rules He established. They offer hope, reinforce faith, and provide a sense of the sacred breaking into the mundane. However, from a scientific perspective, such claims are problematic. Science operates on the principle of methodological naturalism, meaning it seeks to explain phenomena through natural causes and mechanisms. An event that is truly miraculous in the sense of violating natural law would be, by definition, outside the scope of scientific explanation. This does not mean that science denies the possibility of extraordinary events, but rather that it seeks natural explanations for them, or acknowledges them as currently unexplained phenomena rather than supernatural occurrences. Consider the historical context of miracle claims. In ancient times, before the advent of modern science, many natural phenomena that we now understand, such as eclipses, lightning, or disease, were often attributed to divine intervention or supernatural forces. As scientific understanding advanced, these phenomena were gradually explained by natural laws, and the realm of the miraculous seemed to shrink. This historical trend leads some to argue that all so-called miracles are simply events that we do not yet understand, and that with further scientific progress, they too will eventually be explained by natural mechanisms. This perspective does not necessarily deny the existence of God, but it suggests that God works through the consistent and predictable laws of nature, rather than by constantly suspending them. In this view, the universe itself, with its intricate order and its capacity for self-organization, is the greatest miracle, a testament to a divine intelligence that created a system capable of unfolding its own wonders. The beauty lies not in the breaking of rules, but in the profound elegance of the rules themselves. However, for many people of faith, this naturalistic explanation of miracles feels insufficient. They argue that true miracles are not merely unexplained phenomena, but deliberate acts of divine intervention that demonstrate God's personal involvement in the world. They point to instances of inexplicable healings, prophetic visions, or providential coincidences that seem to defy statistical probability. For them, the very purpose of a miracle is to reveal God's presence and power in a way that transcends ordinary experience. The tension here lies in the different epistemologies, different ways of knowing, employed by science and faith. Science relies on empirical evidence, repeatability, and falsifiability. Faith often relies on personal experience, revelation, and tradition. These are not necessarily contradictory, but they operate on different levels of inquiry. The secret here is that the universe is vast enough to contain both the consistent laws of nature and the possibility of extraordinary events that challenge our current understanding. Whether these events are interpreted as divine interventions or as currently unexplained natural phenomena, they invite us to a deeper sense of wonder and a profound humility in the face of the unknown. They remind us that our understanding of reality is always evolving, and that the boundaries of what is possible may be far more expansive than we currently imagine. The power of prayer, beyond the measurable. Prayer, in its myriad forms, is a universal human practice, a deeply personal and communal act of communication with the divine. For billions, it is a source of comfort, guidance, strength, and a means of expressing gratitude, seeking forgiveness, and interceding on behalf of others. Yet the scientific study of prayer, particularly intercessory prayer, has yielded largely inconclusive results leading to questions about its efficacy and its place in a scientifically understood world. Scientific studies often attempt to quantify the effects of prayer, treating it as an intervention that should produce measurable outcomes, such as improved health or reduced suffering. However, this approach often misunderstands the multifaceted nature of prayer and its primary purpose. For many people of faith, prayer is not a magical formula to manipulate physical outcomes, but a form of communion with the divine, a way to align one's will with God's, and a means of spiritual transformation. The value of prayer, in this view, lies not in its ability to suspend natural laws, but in its capacity to transform the inner landscape of the individual, fostering resilience, hope, and a deeper connection to the sacred. Even if a scientific study shows no statistically significant difference in physical outcomes for those who are prayed for, it does not negate the profound subjective experience of the person praying or the person being prayed for. The peace, comfort, and sense of connection derived from prayer are real experiences, even if they cannot be measured by a medical instrument. Furthermore, prayer can have profound psychological and social benefits, reducing stress, fostering empathy, and strengthening community bonds. These are measurable effects, even if they are not the direct miraculous interventions that some might seek. Moreover, the very act of studying prayer scientifically raises profound methodological challenges. How does one control for the countless variables involved in human experience, belief, and the nature of divine response? Can a spiritual phenomenon, which often operates outside the realm of linear causality and material measurement, be adequately captured by the tools of empirical science? For many, attempting to measure prayer in a laboratory setting is akin to trying to measure love with a ruler. It misses the essence of the phenomenon. The secret here is that prayer operates on a different dimension of reality, a dimension that is not necessarily amenable to scientific quantification. It is a testament to the multidimensional nature of human experience, where meaning, purpose, and spiritual connection are as real and impactful as any physical phenomenon, even if they cannot be weighed or measured. It invites us to consider that the universe is not just a collection of particles and forces, but a grand narrative, a cosmic poem, waiting to be read by both the scientific mind and the spiritual heart. The problem of evil, a deeper dive into suffering. The problem of evil, with its raw emotional power and its profound intellectual challenge, remains one of the most significant hurdles for those seeking to reconcile faith with the realities of the world. The sheer scale and intensity of suffering, from the agonizing pain of a child with cancer to the devastating impact of a natural disaster, often seems to defy any rational or theological explanation. How can a benevolent and all-powerful God allow such gratuitous pain? This question has been the source of immense theological debate and personal anguish, leading some to abandon faith altogether, while others seek deeper, more nuanced understandings of divine purpose and human agency. The traditional theological responses, or theodicies, while offering intellectual frameworks, often struggle to provide comfort in the face of raw, immediate suffering. The free will defense, for example, which posits that moral evil is a necessary consequence of granting genuine free will to humanity, primarily addresses human-inflicted suffering. It struggles to account for natural evil, earthquakes, tsunamis, diseases, and famines, which seem to occur independently of human action. Some have attempted to extend the free will defense to natural evil, arguing that a world with consistent natural laws, even if those laws can cause suffering, is necessary for genuine freedom and moral development. However, this argument can feel abstract and unsatisfying when confronted with the concrete reality of a child dying from a genetic disease, or a community devastated by a hurricane. Other theodicies, such as the idea that suffering is a test or a means of spiritual growth, can also feel inadequate, particularly when the suffering seems disproportionate or meaningless. The idea that our finite human minds cannot comprehend God's ultimate plan, while perhaps true, can also feel like a dismissal of the very real pain and injustice that people experience. Perhaps a more fruitful approach is to move beyond the attempt to fully solve the problem of evil in a logical sense, and instead to embrace a more relational and compassionate understanding of God's presence in the midst of suffering. Many contemporary theologians suggest that God is not a distant, impassive observer, but a compassionate co-sufferer who enters into our pain and works for healing and redemption. This view, often associated with process theology, suggests that God's power is not coercive, but persuasive, and that God works in and through the world to bring about good, but does not unilaterally control all events. This perspective does not eliminate the mystery of suffering, but it offers a more intimate and relatable image of God, one who is not the cause of our pain, but a source of comfort and strength in the midst of it. It suggests that the divine response to suffering is not to prevent it, but to be present in it, to share in it, and to work towards its transformation. The secret here is that the problem of evil may not be a puzzle to be solved, but a mystery to be lived, a call to compassion, and an invitation to participate in God's work of healing and redemption in a broken world. The nature of free will, a deeper dive into choice. The debate over free will, like the problem of evil, lies at the very heart of what it means to be human. Our actions are determined by prior causes, whether genetic predispositions, environmental influences, or the laws of physics, then our sense of making genuine choices might be an illusion. This has profound implications for our understanding of moral responsibility, personal identity, and the very foundation of many religious traditions that emphasize the importance of choice in our relationship with the divine. Modern neuroscience, with its ability to map brain activity and correlate it with thoughts and actions, seems to lend support to a deterministic view. If every decision can be traced back to a specific pattern of neural firing, then where is the room for genuine freedom? However, the picture is far from clear. The inherent unpredictability of quantum mechanics, the complexity of the human brain, and the subjective experience of making choices all suggest that a purely deterministic view may be too simplistic. Compatibilism, the idea that free will and determinism can coexist, offers a middle ground, suggesting that freedom is not about being uncaused, but about acting according to one's own desires and reasons, even if those desires and reasons are themselves determined by prior causes. Others argue for a more robust form of free will, suggesting that consciousness itself might have a causal role in the physical world, allowing us to make genuinely free choices that are not fully determined by prior physical states. This is a highly speculative area, but it highlights the profound mystery that still surrounds the nature of consciousness and its relationship to the physical world. From a theological perspective, free will is often seen as a divine gift, essential for genuine love and moral agency. A forced love is not love at all. Therefore, God grants us the freedom to choose, even if that choice leads to suffering and evil. This view emphasizes the relational nature of God, who desires a genuine, freely chosen relationship with humanity, rather than a coerced obedience. The secret here is that the nature of free will remains one of the most profound and unresolved mysteries, sitting at the very heart of what it means to be human. It is a question that continues to bridge the realms of science, philosophy, and theology, inviting us to ponder the intricate relationship between cause and effect, choice and consequence, and the ultimate source of our agency in a universe that is both ordered and surprisingly open to possibility. It suggests that the universe is not a closed, deterministic system, but a dynamic, unfolding reality where genuine novelty and creativity are possible, and where our choices, however small, have real significance in the grand cosmic scheme. Near-death experiences. Glimpses beyond the veil. Near-death experiences, NDEs, stand as one of the most compelling and perplexing phenomena at the intersection of consciousness, brain function, and the spiritual. These profound subjective experiences, reported by individuals who have been on the brink of death, often involve a consistent set of features: a feeling of profound peace and well-being, an out-of-body experience, OBE, where one perceives their physical body and surroundings from an elevated perspective, traveling through a tunnel or void towards an intensely bright light, encountering deceased loved ones or benevolent spiritual beings, a life review where one's entire life flashes before them, and a subsequent return to the body with a diminished fear of death and a transformed world view. While the content of NDEs can vary across cultures and individual beliefs, the core elements are remarkably consistent, leading many to believe they are genuine glimpses into an afterlife or a non-physical dimension of reality. From a scientific perspective, NDEs are often explained as products of brain chemistry under extreme physiological stress: hypoxia, lack of oxygen to the brain; hypercapnia, excess carbon dioxide; endorphin release and abnormal electrical activity in the temporal lobes are some of the proposed physiological mechanisms. For example, the sensation of moving through a tunnel towards a light could be explained by the gradual loss of peripheral vision as blood flow to the brain diminishes, creating a tunnel effect. The feeling of peace and euphoria could be attributed to the release of endorphins, the body's natural painkillers, or other neurochemicals. The life review could be a rapid firing of memory circuits as the brain shuts down. While these scientific explanations offer plausible mechanisms for the sensations experienced during an NDE, they often fall short of fully accounting for the profound subjective meaning, the sense of hyper-reality, and the consistent narrative elements reported across diverse cultures and belief systems. For many experiencers, the NDE is not merely a hallucination or a physiological artifact, but a glimpse into a non-physical reality, a profound spiritual encounter that fundamentally alters their understanding of life and death. The challenge for science is to explain why these specific, often highly structured, narratives emerge consistently across individuals, and why they often lead to such profound and lasting personal transformations. If NDEs are merely brain-generated illusions, why do they feel more real than ordinary waking consciousness for those who experience them? And why do they consistently lead to positive changes in behavior, such as increased altruism, compassion, and a diminished fear of death? This tension highlights a fundamental question: is the brain generating these experiences, or is it mediating them? If the brain is merely generating the experience, then NDEs are purely internal phenomena, products of our physical biology. However, if the brain is mediating the experience, acting as a receiver or a filter for a reality that exists independently of it, then NDEs could be genuine glimpses into a non-physical dimension. This latter view aligns with many spiritual traditions that posit a soul or consciousness that can exist independently of the physical body. The secret here is not about definitively proving or disproving the spiritual nature of NDEs, but about recognizing the profound mystery that lies at the intersection of consciousness, brain function, and the ultimate nature of reality. NDEs invite us to ponder the limits of purely materialistic explanations, and to consider the possibility that our understanding of consciousness and reality is far more limited than we currently imagine. They serve as a powerful reminder that the human experience encompasses dimensions that transcend our current scientific instruments and methodologies, pushing us to explore the edges of our knowing with both scientific rigor and spiritual openness. The profound impact of NDEs on individuals, often leading to a complete reorientation of their lives and values, suggests that these experiences, regardless of their ultimate origin, hold a deep and transformative power that speaks to the very core of human existence. They challenge us to consider that death may not be an end, but a transition, and that the universe may hold secrets far grander and more mysterious than our current scientific paradigms can fully grasp. Mathematics, invented or discovered, a philosophical conundrum. The profound effectiveness of mathematics in describing the physical world has led to a long-standing philosophical debate. Is mathematics invented by the human mind, or is it discovered existing independently of us? This question is not merely academic. It touches upon the very nature of reality, knowledge, and the relationship between our minds and the cosmos. The invention view, often called formalism or nominalism, posits that mathematics is a human construct, a sophisticated system of symbols, axioms, and rules that we have created to help us organize, quantify, and understand the world around us. In this view, numbers, equations, and geometric shapes are useful tools, much like a language or a set of logical rules, but they do not possess an independent existence in some abstract realm. Mathematicians, according to this perspective, are like artists or linguists, creating new forms and structures within a system of their own making. The beauty and elegance of mathematics are a testament to human ingenuity and creativity. This view emphasizes the practical utility of mathematics, its role as a powerful instrument for scientific inquiry and technological advancement. It suggests that the success of mathematics in describing the physical world is due to its internal consistency and its ability to model observed phenomena, rather than its reflection of an inherent mathematical reality. Conversely, the discovery view, often associated with Platonism or mathematical realism, argues that mathematical objects and relationships exist independently of human thought in a timeless, abstract realm. In this view, mathematicians do not invent numbers or theorems. They discover them, much like explorers discover new continents or astronomers discover new stars. The Pythagorean theorem, for example, was not invented by Pythagoras. It was discovered, and it would be true even if no human being had ever conceived of it. The fact that mathematical principles are consistently found to describe the physical world, even in areas where they were not initially applied. For instance, complex numbers in quantum mechanics or non-Euclidean geometries in general relativity, lends strong support to the discovery view. It suggests that there is an objective, mathematical reality that exists independently of our minds, and that our mathematical theories are attempts to map or apprehend this deeper reality. The universe, in this sense, is inherently mathematical, and our minds are uniquely equipped to perceive and understand this mathematical structure. This perspective often evokes a sense of profound awe and wonder, suggesting that we are tapping into a fundamental layer of reality, a cosmic blueprint that underpins all of existence. For many, the discovery view resonates more deeply with the experience of doing mathematics. Mathematicians often speak of feeling as though they are uncovering pre-existing truths rather than inventing them. The sense of inevitability and universality in mathematical proofs, the way different branches of mathematics unexpectedly connect and illuminate each other, and the uncanny ability of abstract mathematical concepts to predict physical phenomena, all point towards an independent reality. This view also aligns more readily with theological perspectives that see God as the ultimate source of all order and rationality. If mathematics is discovered, then it could be seen as the very thoughts of God, the blueprint of creation, the language through which the divine communicates its order and beauty. The fact that our minds are capable of understanding these divine thoughts suggests a profound connection between the human intellect and the cosmic order, a reflection of the divine image within us. The secret here is that the debate between invention and discovery in mathematics is not just a philosophical exercise. It is a profound inquiry into the nature of reality itself. It invites us to consider whether the universe is merely a collection of random events, or if it is imbued with an inherent, intelligible order that speaks of a deeper underlying intelligence. The answer to this question shapes our understanding of science, our understanding of faith, and ultimately, our understanding of ourselves and our place in the grand cosmic scheme. Fractals, Fibonacci, and the divine patterns of nature. The universe, far from being a chaotic jumble, reveals an astonishing propensity for order and pattern, often expressed through elegant mathematical relationships. Two particularly captivating examples are fractals and the Fibonacci sequence, which appear with such pervasive regularity in nature that they seem to whisper of divine patterns woven into the very fabric of creation. These are not mere coincidences. They are the result of underlying mathematical principles that govern growth, efficiency, and optimization in natural systems, suggesting a profound harmony between the abstract world of numbers and the concrete reality of the physical world. Fractals are complex geometric shapes that exhibit self-similarity at different scales, meaning that a small part of the fractal looks similar to the whole. This property, known as self-affinity, allows for infinite detail within a finite space. They are generated by repeating a simple process over and over again, leading to incredibly intricate and beautiful patterns. We find fractals everywhere in nature. The branching patterns of trees, the intricate structure of snowflakes, the meandering paths of rivers, the jagged coastlines, the branching of our own circulatory and nervous systems, the structure of clouds, and even the patterns of lightning. The mathematical equations that generate fractals are surprisingly simple, yet they produce infinitely complex and beautiful forms. For example, the Mandelbrot set, one of the most famous fractals, is generated by a simple iterative equation, yet its visual representation reveals an astonishing, never-ending complexity and beauty. The ubiquity of fractals in nature suggests that these mathematical principles are fundamental to the way the universe organizes itself, creating maximum surface area or efficient distribution systems. For many, the elegance and pervasive presence of fractals in nature are not just scientific curiosities. They are seen as signatures of a divine hand, evidence of a cosmic artist who uses mathematical principles to create beauty and order. They suggest that the universe is not just governed by laws, but imbued with an inherent aesthetic and mathematical harmony, a testament to a profound intelligence that delights in intricate patterns and self-organizing complexity. The Fibonacci sequence, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, is a series of numbers where each number is the sum of the two preceding ones. This sequence, discovered by the Italian mathematician Leonardo of Pisa, Fibonacci, in the 13th century, and the related golden ratio, approximately 1.618, often represented by the Greek letter phi, appear with astonishing frequency in nature. The golden ratio is found when the ratio of two numbers in the Fibonacci sequence approaches 1.618 as the numbers get larger. This ratio is considered aesthetically pleasing and has been used in art, architecture, and design for centuries. In nature, the Fibonacci sequence and the golden ratio manifest in a myriad of ways. In the spiral arrangement of seeds in a sunflower head, the arrangement of leaves on a stem, phyllotaxis, the branching of trees, the uncurling of fern fronds, the patterns of pine cones, the structure of seashells, and even the proportions of the human body. These patterns are not random. They are often the most efficient way for plants to pack seeds or leaves, or for structures to grow in a balanced and stable manner. For example, the spirals in the sunflower head follow Fibonacci numbers, because this arrangement allows for the maximum number of seeds to be packed into the head. The pervasive presence of these mathematical patterns in living organisms suggests a deep, underlying mathematical order to biological growth and form. For those with a spiritual inclination, these divine patterns are seen as evidence of a creator who designed the universe with inherent mathematical beauty and order. They are like a hidden code, a secret language embedded in creation, waiting to be discovered by those who seek to understand the universe's deepest truths. The secret here is that the universe speaks in numbers, and its language is one of profound beauty and intricate design, inviting us to see the divine not just in grand cosmic events, but in the subtle, elegant patterns that surround us every day, revealing a cosmos that is not just governed by laws, but imbued with an inherent aesthetic and mathematical harmony. The multiverse, Infinite universes, infinite possibilities. The concept of a multiverse, once relegated to the realm of science fiction and philosophical speculation, has now entered the mainstream of theoretical physics, offering a tantalizing, if currently untestable, vision of reality. The idea that our universe is not the only one, but rather one of many, perhaps an infinite number of universes, arises from several different theoretical frameworks, each with its own unique implications. One of the most prominent multiverse theories comes from inflationary cosmology, a theory that describes the rapid expansion of the universe immediately after the Big Bang. If inflation is eternal, meaning it never truly stops everywhere, then new universes could be constantly bubbling off from our own, each with potentially different physical laws, different fundamental constants, and different initial conditions. Imagine an infinite cosmic foam, with each bubble representing a separate universe, a self-contained reality with its own unique properties. In some of these universes, gravity might be stronger, or the speed of light might be different, or there might be more than 3 spatial dimensions. Most of these universes would likely be sterile, unable to support the formation of complex structures like stars, galaxies, or life. But in an infinite multiverse, it is statistically inevitable that some universes would have the precise conditions necessary for life to emerge. Our universe, in this view, is not special in its design, but merely one of the lucky ones, a cosmic oasis in a vast, mostly barren landscape. Another multiverse theory comes from quantum mechanics, specifically the many worlds interpretation, MWI. This interpretation suggests that every time a quantum measurement is made, the universe splits into multiple parallel universes, each representing a different possible outcome. For example, if a quantum particle can be in 2 places at once, when we measure its position, the universe splits into 2, the particle being in one position in one universe, and in the other position in the other universe. This process of splitting happens constantly, creating an ever-branching tree of parallel realities. In this view, at every decision you make, every path you don't take, actually happens in a different universe. If you chose to turn left, there is another you in a parallel universe who chose to turn right. This idea, while mind-boggling, offers a way to resolve some of the paradoxes of quantum mechanics, such as the measurement problem, by suggesting that all possible outcomes are equally real. The implications are profound. If the MWI is correct, then there are an infinite number of parallel universes, each with a slightly different history, a slightly different version of you, living out all the possible consequences of every choice ever made. While currently untestable, the MWI offers a radical and thought-provoking vision of reality, one where every possibility is realized, and where the universe is far grander and more complex than we can ever perceive. String theory, a leading candidate for a theory of everything that unifies all the fundamental forces of nature, also suggests the existence of a multiverse. String theory posits that the fundamental constituents of reality are not point-like particles, but tiny, vibrating strings of energy. The theory requires extra spatial dimensions beyond the 3 we experience, and the way these extra dimensions are curled up or compactified determines the physical laws of our universe. It is estimated that there are a vast number of possible ways to compactify these extra dimensions, perhaps as many as 10 raised to the power of 500, each corresponding to a different universe with different physical laws. This landscape of possible universes, each with its own unique properties, provides another theoretical basis for the multiverse. Our universe, with its specific set of physical laws, is just one of many possible universes in this vast landscape. The secret here is that the multiverse, while still a speculative concept, is not just a philosophical whim, it is a natural consequence of some of our most promising scientific theories. It challenges our sense of uniqueness and expands our understanding of reality to an almost incomprehensible scale, inviting us to consider that our universe might be just one small part of a much larger, more diverse cosmic tapestry. The simulation hypothesis. Are we living in a computer? Even more mind-bending than the multiverse is the simulation hypothesis, the idea that our entire reality, including our consciousness, is an elaborate computer simulation created by a more advanced civilization. This idea, once confined to science fiction, has gained traction in recent years as a serious philosophical and even scientific proposition. The argument, often attributed to the philosopher Nick Bostrom, goes like this. If a civilization reaches a certain level of technological maturity, they would likely develop the ability to create highly realistic simulations of their ancestors or of past societies. If they can do this, and if they run many such simulations, then the statistical probability suggests that we are more likely to be living in one of those simulations than in the original base reality. I did it like this. If you have one real world and a million simulated worlds, the odds are 1,000,000 to 1 that you're in a simulation. This argument rests on a few key assumptions: that consciousness can be simulated, that advanced civilizations would be interested in running such simulations, and that they would not be prevented from doing so by some unforeseen technological or ethical constraint. While these assumptions are debatable, the logic of the argument is compelling, and it forces us to question the very nature of reality, consciousness, and existence. If we are living in a simulation, what would that mean? It would mean that our perceived reality is not the ultimate reality, but rather a constructed one, governed by the rules and parameters of the simulation. The laws of physics would be the code of the simulation, and our consciousness would be a simulated consciousness, a product of the simulation's programming. This idea, while unsettling, is not necessarily a bleak one. A simulated reality could be just as meaningful and real to its inhabitants as a base reality. Our experiences, our relationships, our joys and sorrows would all be real within the context of the simulation. The simulation hypothesis also offers potential explanations for some of the universe's deepest mysteries. The fine-tuning of the universe, for example, could be explained as a deliberate choice by the simulators to create a life-permitting universe. The mathematical nature of reality could be a reflection of the underlying computational structure of the simulation. Even the existence of a speed limit in the universe, the speed of light, could be seen as a computational constraint, a processing speed limit of the simulation's hardware. While currently untestable, some physicists have proposed potential ways to test the simulation hypothesis, looking for glitches in the fabric of reality, or for computational limits that might manifest as subtle anomalies in physical laws. The secret here is that the simulation hypothesis, while highly speculative, is a powerful thought experiment that challenges our most fundamental assumptions about reality. It invites us to consider that our perceived reality might be just one layer in a much larger, more complex computational hierarchy, and that the ultimate nature of existence might be far stranger and more mysterious than we can ever imagine. It is a profound secret, if true, that would redefine everything we thought we knew about the universe, our place in it, and the very nature of what it means to be real.